So good morning, students. This is the 10th lecture in control systems. So we are in the module 2. Last day, that is Monday, we had started the module 2, and we had found that module 2 is having mainly three parts. That is, first part is the block reduction technique, that we are trying to find out the transfer function of the given system. Second part is signal flow graph, and third part is whatever transfer function we find from signal flow graph or block reduction technique, we are supposed to find out what is the stability of that. So stability analysis of the found transfer function by block reduction or signal flow graph is going to be the third part in this module. So we had started the module 2, and we had seen the very basic rules for finding out the transfer function, and there are kind of 10 rules which is given in the book of M. Gopal, page number 110, 111. So out of that we had seen the first 5 rules, and I had given a case that I had shown what is to be done in the system if the summing point is shifted um, afterwards. That means after the gain block. So there was a gain block initially, and there was a summing point, and what is to be done if we want to transfer or shift the gain block after the summing point, or if we want to transfer the summing point before the gain block, then what is supposed to be done. So that was one very small case with that we had uh, stopped in the last. So today we are going to see if the summing point comes first in the left side and if the gain block is there afterward. So in the previous case, whatever numerical we had did, their input was there, then there was the gain block, then there was summing point, and summing point was also having another input too. So what we had done was in the last day, then we had shifted the summing point before the gain block. Then what we had seen was that 1 by gain, that one block we had to insert in the input 2. So that was thing we had seen. So today what we are going to start with is, so I'll remove this slide. Today what we are going to start with is if there is a summing point first and then there is a gain block. Now if we want to shift the gain block before the summing point, then what the changes we are supposed to make. So these are very easy things, but as this is the starting point, I would like to tell you all these things. So we will start with the handwritten notes that I have written, and with that we will start with today's discussion. So let me share the my notes. Okay, I guess my note is visible to you. So last we had done this. So this was the first case. So there are mainly 2, 3 rules, basic rules. If we follow that, we'll understand, or we can solve all the numericals in case of this block reduction technique. So last we had done this. So this was a gain block, and this was the summing point. What we wanted to do was we had brought the summing point before the gain block, and we had found that in that case, if the gain is 3, we had to add another block with the input 2 that was having gain of 1 by 3 or attenuation of 3. So this was a change we had done. Today we will start with this is another case. I'll make it a little big. So with another case which is saying that if the summing point is at first, that means first there comes the summing point. So you can see here, this is case number, this is a new case. So shifting a summing point after the gain block. So what is the here? We are giving the input as 3. So there is the input 1, and there is another input which is input 2, and this input 2 is actually with a negative. That means input 1 minus input 2. That will go to the gain block 4. So what input I am giving here is 3. What input I am giving here is 1. So here I have to write that 3 minus 1. Okay, that means the input going to the gain block, actual gain block is 2. So 2 volt. So if this is 3 volt, this is 1 volt, but this one is minus. So this is 3 minus 1, that is 2 into 4. So that's why the output is 8. Okay, now what we want to do is, now we want to shift this summing point after the gain block, or if we want to shift this gain block before the summing point, then what happens? So if you don't do anything, if you just shift it, okay, without adding or without compensating for this shift. Okay, so in this case B, so this case B is actually a wrong system, because this was the input 3 and 2 given, output was obtained as 8. But in this case we have just shifted the gain block before the summing point, or we have just shifted the summing point after the gain block, both are same thing. Then what is the case you can see? So here it is coming to be 1 minus 1, and here this 3 is actually getting multiplied with 4, and in this case you are getting this input is 12, this input is minus 1, so 12 minus 1, 11 is the output. So actually previous case, if you see, there are two flows. The first flow is 3 is flowing with 4 and coming at the output. So the first flow is 12, and second flow is 1 and minus 1. So there's minus 1 into 4, so minus 4 is coming at the output. So these two inputs are getting superimposed at this point SP. So it is actually becoming 3 minus 2, but actually there are two flows of the inputs. One is 1 getting multiplied with 4 coming at the output with a negative sign. Another is 3 multiplied by 4 coming at the output with a negative sign. So net output is 12. But here in this case, if you are finding, this 1 is coming at the output directly. So this 1 multiplied by 4 thing is not happening. Okay, in this case. 3 multiplied by 4 thing is happening in this case, but 1 multiplied by 4 thing is not happening. And that's why previous case the output was 8. In this case the output is 11. So what I have to do is, if I put another gain block of 4 here, because here you can find 1 into 4 was the output that was coming at the output. So if I put a 4 here, so another block of 4, because this 4 I have taken before this SP, so now this 4 becomes exclusive for this input 1. Now this input 2 also require another gain of 4, so one block of gain 4 I have to insert here. So this is the correction. So first diagram is the actual diagram, second diagram is just shifting, no correction is done, but the third diagram is the corrected diagram. Okay, and this is the thing that you have to learn, that is the third diagram. This is what you have to learn. So if we are shifting the summing point before the gain block, one gain block of the same gain we have to bring in the this point, and this also should be arrow here, sign should be negative sign. Okay, and then output we are going to get is 1 into 4 minus and 3 into 4, so 12 minus 4, in that case we are going to get 8 volt at the output. So you have to imagine this. So here there is an arrow sign upward, and here there is a minus sign. Okay, so in that case this diagram C is the correct output for the system shown in A, whereas this case B is actually the wrong. So here we have just shifted, but we have not compensated. So third step, that is the diagram C, is the shifted and compensated. So mainly what you have to do is this compensation. So previous case, in the case whatever we had discussed last day, here there was a 1 by 3, because we had been shifting the gain block after the summing point. In this case we are shifting the gain block before the summing point. So when you are shifting the gain block after the summing point, in the path below we have to multiply a gain of 1 by 3, and if we are shifting the gain block before the summing point, we are supposed to multiply it with a gain of g or 4. So this is what we are supposed to understand. Now there is another important concept of takeoff point. Okay, so here also we are keeping everything same, but here this is the point. So if you can see, this is the input x that is getting multiplied with g, so g is called as a forward path gain, and output is xg. Yeah. And the same thing you are taking at the out feedback. So this point is called as a takeoff point. Okay, so from the takeoff point you are taking the output as xg. So whatever is the output, the same thing is will be the signal xg. So whatever is the feature of output, the same thing will be the feature of xg. Okay, so if this is input is x, forward gain is g, output is xg. So from here also the output will be xg. Now if you are shifting this takeoff point before the gain block, okay, like as it is shown here, so this input is now taken before the gain block. What happens? So if you are giving this input x, output is xg, and this takeoff point also is getting the output as xg. That means xg signal is propagated back. But if you are taking this takeoff point before this gain block, like here, so here this x is not getting multiplied with g. So actually here in the top diagram, the signal is getting multiplied with g, and then you are taking it feedback. But here in the below diagram, the signal is not getting multiplied with g. So whatever your signal you are taking back, it will be X only, but what you want is actually XG. Hence, here also you have to do the correction by inserting a G block in the takeoff point feedback path. So this is another diagram where what we are doing is there is a takeoff point xg, output is xg because x input is getting multiplied with g. Now if we want to take this takeoff point before the gain block g, what we have to do is we have to multiply one gain of g in this point. Hence input is given as x, output is being obtained as xg, and this feedback output is obtained as xg. So what we are going to see is what is the input, what is the output, and what is the feedback. Internally, whatever changes we are doing, it should not be visible from outside. So internally we are making some change. All these changes we are making so that our block reduction process becomes easy. Because when you will be given actual block reduction numericals, you'll be finding that lot of loops are entangled. Okay, so many loops are overlapping with each other. So in that case, if you want to find the solution of that block reduction technique, in that case, first what you have to do is shifting some point, shifting some block here and there. And while shifting some block or point or summing point here and there, then all these three techniques that I have shown you so far, that is shifting the summing point before gain block, shifting the gain block before the summing point, shifting the takeoff point before a certain block, okay, or interchanging two summing points. Certain cases interchanging of two summing points are allowed, and interchanging of summing point can be done without any kind of correction. So one numerical we will do, we will just interchange two summing points. So whichever external input was connected to whichever summing point, it will remain with that summing point only. But just if there are appearing two summing points SPs, unconditionally without any change, you can interchange those summing points. So that also we will see through another numerical. So this H, whatever H point we have seen, so if we are taking the takeoff point, if we are taking the takeoff point before a gain block, then what is the correction we have to do? We have to put another gain block in the feedback path. Okay, so put a gain block with the feedback path. So this is another change, and then last rule we will see. Okay, so this is the last rule that we are going to see, shifting a takeoff point after the gain block. So same thing, whatever we have shown in the previous slide towards the end with X and G, here I have shown the same thing by means of some figures. So 2 is the input given, 4 is the gain block, and output is 8. Okay, now here is the feedback. So this feedback is actually taken from the input itself. That means whatever is the input given, same thing is coming as a feedback. That means this feedback is actually equal to 2. But now what I'm doing is, because of we want to shift it, or because we want to get the final reduced value of the circuit transfer function, we have to shift this point outward. Okay, so if you are shifting this point outward, see what we are getting. So we are giving input 2, this is getting multiplied with 4, that means 8. So here the signal is 8, so that signal is coming at the output. And as you have taken the feedback from here, this signal also will be 8. But what was the actual circuit? Actual circuit, this feedback signal was 2. But in this case, as we have shifted the takeoff point after the gain block, we are finding that feedback signal is coming to be 8. And this is not equal with the previous system A. So what we have to do is, we have to put a gain block with 1 by 4 gain or attenuation of 4 in this feedback path. Then what we are getting? So this 8 is coming and getting multiplied with 1 by 4, because this 1 by 4 is the correction. So what is the rule? That if you are shifting a takeoff point and taking it after the gain block, in that case, we have to input a 1 by 4 gain block in the feedback path. So if we are shifting, so previously it was like this, previously there was the feedback path first and there was the gain. Okay, now what we want to do is, we want to shift this takeoff point after the gain path. So if you are taking the feedback after the gain path, that means this input is getting multiplied with the gain, and whatever is coming here, this is actually an enhanced or increased version of the signal. Now this signal is being fed back, means output will be high, but we want the output to be low itself, same as the input. That means here you have to put a 1 by gain block, or a gain of 1 by 4 in this path, so that this 8 is multiplied with 1 by 4 and you are getting output as 2. So internally, whatever changes we are making, so internally how many changes we have made? Internally we have shifted the takeoff point, that is first change. And as we have shifted the takeoff point, then the feedback signal amplitude is getting multiplied by 4 times. Hence, to compensate that, we are supposed to put a 1 by 4 gain block in the feedback path. So that again is going to give us the output as 2. So there are 3 output points. One is input, one is actual output, one is feedback output. So as in circuit A, it was the same thing. Input was 2, actual output was 8, feedback was 2. And circuit below, it is also like that. Input is 2, output is 8, and gain is output is 8, and feedback is also 2. That means from 1 directly you will come to A, from directly you have to come to C. So this B is actually a wrong thing, because in this B, shifting has happened, but compensation has not happened. So there are 2 steps whenever you are shifting any block before or after to any block, any point before or after to any point. There are 2 things. First, shifting has to be done, and next, compensation. So you do the shifting very well. Generally what we have found, shifting students are doing quite well, but the compensation part they are not able to understand. G से multiply करना है, G से divide करना है, all those things you are not able to understand. So apply your brain, apply your logic. You have to see whether the multiplication is already happening or not. If multiplication is happening, then in feedback path also you have to do it, that multiplication thing, G or 1 by G accordingly. So as we keep on solving numerical, we'll be able to understand all these things in a better way. So now I'm stopping this presentation, but I will open another presentation which is actually the numerical part. So let me do that. Give me some time, and what I'll do is I will open a PDF, and through that PDF I will explain some numerical, and there we will see exactly how to solve some numerical by using block reduction technique. So from the book, whatever numerical is there, you can solve. It is there at page number, I think 109 or so. Okay. I'm mainly going through my notes only because books are there already with you. So whatever is given in my note, I will do that. Hello. Okay, so I have launched my notes, and here the same rules and everything you can find out. So there's a PDF, it can be given to you. So it is saying again the set of rules. So whatever I have done, the same thing I'm going to repeat. So the same thing is given in the book of M. Gopal. You can find. So last day through a table we had seen all this. So x1 is coming, x2 is coming. So x1 minus x2 is here. Then again x3 is getting added to it. So this is x1 minus x2 plus x3. So we are doing actual numerical. So it's a 23-page note. It will be forwarded to you. A lot of numericals are solved here. You can check. Now here x is the input given to 2 things. So G1 and G2, it's a parallel path and they're getting added. So xG1 and xG2. Okay. And they're getting added here. Well, this is the one forward path. So both these are forward paths. Be very careful about the arrows. So both the arrows are from left to right. So top part is xg1, bottom part is xg2. So this is actually xg1 plus xg2. So if you take x common, so input is common, you can say g1 plus g2. So whenever this kind of things are there, you can resolve it to g1 plus g2. So overall system gain is g1 plus g2, input is x, output is x, g1 plus g2, that is y. So in this system, it's a open loop system because there is no feedback. Again, you can see number three, what you are finding is x1 is given and this is multiplied with g, so x1g. Now x2 is coming here, but this is minus x2 because here it is negative. So from left side it is coming x1g, bottom it is coming minus x2. So what is the output? X1g minus x2. In this case, if we want to shift this summing point before the gain block, okay, so this summing point is taken before the gain block or gain block is taken after the summing point, but input should be same x1, this input should be same x2, and output should be same x1g minus x2. So what we are doing in that case, as we have shifted the, so I told you there are 2 steps. One is shifting. So here shifting has happened. So this with x2 you have shifted this summing point before the gain block, so gain block has gone afterward. So now in this case, if you want compensation, if you want to keep the output same, what you have to do is you have to multiply a 1 by g in the x2. So now what you are finding here is this is x1 is coming minus x2 by g, because now this x2 will get multiplied with g. So x1 minus x2 by g, which all thing, so this overall total thing is getting multiplied with g. That means it is becoming x1g minus x2, because these g and this g, they get cancelled. So what we are finding is x1g minus x2. So this is same as the top one. Now again, whatever we have discussed today, that shifting of gain block before the summing point. So this is what we have done in this lecture. So now here, first scenario, so this was classic diagram A. X1 is the input we are giving, and minus x2 is coming from here. So actually x2 is coming, but this sign is minus. So here it is x1 minus x2 multiplied by g. This is x1 minus x2g. Now what we want is, we want to prepone, or we want to take this g before the summing point. So now shifting has happened. So after shifting has happened, what we are finding is we are supposed to multiply this x2 with a g. Then only this x1g minus x2g can be kept constant. So now you can find here, so this g, if you are taking it before, this g also you have to take before the summing point and towards x2 also, because what you are finding is x1 minus x2, this superimposition is happening first, and then it is getting multiplied with g. So if you are shifting this g before the summing point, the same shifting has to happen inside of x2 as well. So it should not only happen towards x1, the same thing should happen towards x2 as well. So then what we are finding is this one gain block had to be split into two gain blocks. So in this case, in this top case, with one amplifier we could get the output as x1 minus x2g. But if we are taking this gain block before the summing point, instead of one, we will be requiring two amplifiers. So if you want circuit optimized point, then this below circuit is not optimized, because here there are two gain block with same gain, but this top one block is a optimized block, because only with a single gain block we can get the output as x1g minus x2g. And again the same thing as we had seen here, that is x is given, g is here, this is xg. Again takeoff point is xg. So if we take the takeoff point before the gain block, then there a gain block has to be inserted in the feedback path. Same thing here, number 6, that actually whatever is the input is given, the same thing is being taken as the feedback. But now if you want to shift this takeoff point after the block g, then a gain of 1 by g has to be inserted in the feedback path that is there. And here it is not being seen, but I can tell you x1 is the input, and so all this whatever you had seen up till now, 1 to 6, they were all open loop systems. Now at 7 you are finding closed loop system. It has got cut, but don't worry, all these proofs we have already done in the previous lecture. It is x1 is the input, x2 is the output, and it's a negative feedback. So x2 by x1, that is output by input, is g divided by 1 plus gh. So this transfer function is g by 1 plus gh, and it is x1 is given, x2, so g by 1 plus gh is the equivalent circuit. And if it is negative feedback, if it is negative feedback, so in the next page, I think towards end, it is given here. Yes, so it is like this. So x1 is given, x2 is output, and negative feedback g and h. So x2 is equal to g by 1 plus gh into x1. So that should happen. So, okay, so x2 by x1 should be equal to g by 1 plus gh. Likewise, it should happen. Now we are going to see the actual transfer function of different systems. So this is the same thing. RS is given, CS is given. So CS by RS is G by 1 plus GH. So there is nothing difficult here. We have already proved it in the previous lecture. Now the same circuit, but instead of negative, now we are giving positive feedback. So RS is the input, CS is the output. We call it TS. Okay, so we call it TS. Some book it is called as HS also. So H is actually is the transfer function, but here also we are saying HS. HS is the feedback signal, so we should not get confused. That is, some book HS equal to CS by RS, we might use TS equal to CS by RS, and HS is the feedback gain in that case. So what main thing I'm telling you is, don't get stuck to any symbol. So any symbol can appear anywhere. Somebody can say that yes, forward path gain is AS, possible. Somebody can say is that feedback path gain is BS, that is also possible. Okay, so don't worry about symbols. Whatever symbol you use, depending on the numerical, it is okay. So it doesn't matter. Generally, here it should be output by input. That's all. and here it should be g by 1 minus g or g by 1 plus g. As this is positive feedback, it is 1 minus gshs. Now we are going towards more critical things. So here it's a 3 input symbol. So it is x1, x3 is plus minus. That means the x3 can get added or subtracted to x1. We don't know for sure. Okay, but x2 is getting subtracted. So what is net cs? Cs is x1 plus minus x3 minus x2. So here there are 3 inputs, x1 plus minus x3 and minus of x2. So you are finding that output is equal to x1 minus x2 plus minus x3 likewise. This is the same diagram as we have found previously. So x1 is coming, getting multiplied with g, it is coming here, nothing is given means it's positive, and x3 is coming in a positive mode, so it will be x3 plus x1g. So s you can write, you cannot write, but I will write s every time. Okay, so it is x1s into gs. So x1s into gs, this is the first part, and second part is x3s. So x2, what is the output, is equal to x1 into g plus x3. Next, another thing you can find, this is x1 is coming, x2 is coming. So first they are getting added. So this is actually superposition, and then they are getting multiplied with g. Okay, so x1 plus x2 into g. So x3 is equal to x1 g1 plus x2 g1. So x2s are the inputs, g is the gain, and then g1 into x1 plus x2. So here inputs are getting added, gain is same. Previous circuit what we have found was input was same and two parallel paths g1 and g2. So in that case what we found was x into g1 plus g2. Same thing you can find here. So this is another configuration. What you are finding is x1 is coming with a gain of g1, x2 is coming with a gain of g1. So it is x1 plus x2 into g1 likewise. Now this is actually called as cascade. So these are very small numericals. They are not for exams, but they are for your understanding. That's why the small 8-10 numericals are done initially. So now this can be your plant dynamics s by s plus 2, or this can be the controller dynamics. I'm sorry, first there comes controller. So input is given to the controller, then actuator. So actuator can be 10 by s plus 1, and then there is the plant. So 1 by s is integrator. Okay, so this can be, the plant can be an integrator with a gain of half. So 0.5, that is a numerator, that is called as DC gain, and generally given by capital K. Okay, so in this case the gain is equal to half, and 1 by s is the symbol of integration. Okay, so in this case it's an open loop system obviously, and you are finding three things are connected in cascade mode. So how can I find the overall transfer function Cs by Rs? So Cs by Rs is s by s plus 2 into 10 by s plus 1 into 0.5 by s. If you just multiply everything, denominator you are getting s into s plus 1 into s plus 2, and numerator is 5s. And don't go on applying the concept of characteristic equation and all those things here, because this is not a closed loop system, this is an open loop system. Here also this is a open loop system. Don't think it's a closed loop system. Closed loop system means there should be a feedback. Here there is no feedback, all the systems are going towards forward. So previous system, whatever you had seen in numerical 6, there is the number 6, this is actually called as a cascade system. Cascade means all the system blocks, they are connected one after another. We call in series, but better you don't call series, better you call cascade. Okay, and then what is coming is, this is called parallel connection. Parallel connection means these are the three blocks and they are connected in parallel. So what will be the average overall transfer function? But one change you can see here is this 10 by s plus 1 is connected in subtractive mode. S by s plus 2 and 0.5 by s, they are in additive mode, but 10 by s plus 1 is in subtractive mode. So what is CS? CS is equal to s by s plus 2 minus 10 by s plus 1 plus 0.5 divided by s. Now here point number 8 is the first numerical, so I will keep on explaining all the numericals as much as I can. Okay, and remaining things already will be given to you, and you can always practice from my notes. There are many books. Okay, so a humongous amount of numericals are available on internet or something. I will provide you all the numerical and solution. You just keep on practicing yourself. And सिर्फ आप देख रहे हो so it is not sufficient. You have to solve all this numerical by hand. Lot of blocks you have to keep on drawing. Okay, so first see the numerical, you know how to solve it, and then close it down. Okay, and then you solve it on your own. So start with the initial block diagram, and then keep on solving and get the final result. Okay, so here there is a very basic, very easy kind of numerical, but you will be finding that all the big numericals we are solving towards the end, this kind of thing will come. Okay, so here the loops are like this. So G1 H1 is one loop. Okay, and whatever is the loop you find here, that thing is having a feedback with H2, and H1 and H2 both are negative feedback, and you have to start solving from the inside and then you have to come to the outside. So input is RS, output is CS. So if this kind of thing is given, first you have to understand, first you have to get a loop which is not entangled. That means entangled means एक loop के अंदर दूसरा loop घुसा हुआ है, वैसा नहीं रहना चाहिए. Okay, so we are finding that this is a very clear cut numerical because this is a very basic numerical. Initially we are solving this, that's why it's a very basic numerical. So we are finding that the loop, this one, first loop, loop 1 and loop 2, they are clear cut, they are separated. So first you are solving transfer function for loop G1. That means this whole thing G1 and H1, they can be represented as G1 by 1 plus G1 H1. As this is negative feedback, that means this whole thing, it can be represented as G1 by 1 plus G1 H1, like this. So after this, the step is here, and you have to say that loop 1, the whole loop 1 is having a transfer function of G1 by 1 plus G1 H1. And whenever you are making this G1 by 1 plus G1 H1, this summing point is actually going inside this. Okay, so this summing point is actually uh, coming down or getting assimilated inside this transfer function. So this whole transfer function of this loop 1 is G1 by 1 plus G1 H1. Now you are finding that this becomes now forward path gain. Here the forward path gain is G1, but whenever you are solving this whole thing, now this becomes a forward path gain. And what is the feedback gain? Feedback gain is H2. So for loop 1, feedback gain was H1 and it was negative feedback. For loop 2, feedback gain is H2 and it's also a negative feedback. So now this G1 by 1 plus G1 H1, this will be taken as a G. This will be taken as a forward path gain. And you are finding this is again another loop. Okay, loop means it's a closed loop where G1 by 1 plus G1 is the forward path gain. So now overall CS by RS is equal to this thing, G1 by 1 plus G1 H1. Now this is the forward path gain. So 1 plus G, so G1 is this thing. So it is not only G1 but G1 by 1 plus G1 H1 plus 1 plus GH. But in case G is G1 by 1 plus G1 H1 multiplied by H2. So from, again I'll explain this thing to you. So first, there is a first numerical where more than one loop we are finding. So there are two loops. In the first loop, G1 is the forward path gain and H1 is the feedback gain with negative feedback. So if you solve it, it becomes G1 by 1 plus G1 H1. This whole thing you can take as capital G. Okay, and now we are having another loop where forward path gain is capital G, feedback path is H2. Okay, now what will be the CS by RS? It is G divided by 1 plus G into H2. And what is G? G is previously found as G1 by 1 plus G1 H1. So G, instead of G, you substitute G1 by 1 plus G1 H1 into divided by 1 plus G into H2. So instead of G, substitute G1 by 1 plus G1 H1. And then you have to do this kind of multiplication. So how to do this multiplication? It's very easy. Don't get confused. So 1 plus G1 H1 will come here. So 1 multiplied by the denominator, so 1 plus G1 H1 will come here. And numerator, whatever part is there, okay, it is also fraction. So its denominator is 1 plus G1 H1. And denominator, whatever is there, it is also fraction. So that denominator is also 1 plus G1 H1. So G1 H1 denominator at the numerator and G1 H1 denominator at the denominator, both things will get cancelled. So what you will be finding finally is G1 divided by 1 plus G1 H1 plus G1 H2. So this is a technique, this is a calculation you should practice so that after this very fast you should be able to come here. Here अभी देख देख के बैठ के करने का time नहीं है, because very fast you have to understand that for numerator and denominator both are a by b form, and for both case b are same. What is the denominator part? 1 plus G1 H1. Here also denominator part is 1 plus G1 H1. So take the multiplication and cancel the denominator part. So what will remain is G1 divided by 1 plus G1 H1 plus G1 H2. Now here you can take G1 common. If you take, it's okay. If you don't take, that's also okay. So G1 by 1 plus G1 into H1 plus H2. So in exam, whenever you are doing, don't leave it like this. C by R is equal to a very complex form, Lambasa form. No, it will not do. You have to bring it down to a numerator polynomial as well as denominator polynomial. And one more thing you can check here is S is not written anywhere except CS and RS. Here while solving this G and H, I have not written S anywhere, and everything is in capital. So G and H, they are not small, everything is in capital. That is the first thing. And S is not written anywhere. So these are the practices you can do. I will go for the next numerical. Okay, so try to understand this. This is also another numerical. So I have actually slowly I have developed the level. Okay, that's why this kind of thing will not find generally in books. That's what I'm asking you to see my notes first, and after you complete my notes, all these 23 pages, so there is another document, all these numericals when you solve, then go for any book, no problem. Okay, now here it's also a one loop circuit. But what is the thing? In the forward path you are having, there are two gains. So first gain is 18 by s into s plus 2. Second gain is s square by 2 into s into s plus 1. So what is the first step? First step is multiply these two. Okay, because these two things are in cascade, you just multiply these two. So what it becomes, 18s square divided by 2s into s plus 1 into s plus 2. So now that becomes forward gain of G. Okay, so as soon as you're multiplying these two things, what you're getting is 18s square divided by s into s plus 1 into s plus 2. That becomes now the forward path gain. And what is the feedback? Feedback gain is 60 by s, and you are finding that feedback gain is positive. That means numerator will be 1 minus GSHS. So you can find here now CS by RS, directly you can write 1 minus GS. What is GS? 18 s square divided by s into s plus 1 s plus 2 into 2. So this is the part. Okay, so 18 into s by s plus 2, s square divided by 2 into s plus 1. So this is the G part. Same G you can find here. Okay, so G divided by 1 minus GSHS. Okay, so what is HS? HS is 60 by s, and GS is 18s square divided by 2s into s plus 1 s plus 2. Now you can do all the multiplication. So you can find here that at the numerator, okay, the denominator of the numerator is 2s into s plus 1 s plus 2. Here also it is 2s square. Okay, so only one s will go and get multiplied with the numerator part. Okay, so here it is s square into s plus 1 s plus 2 here, but this s and this s is actually getting cancelled. So that is another thing you can do. Okay, so this s and this s square is getting cancelled. So what you are finding here is like this. So 18 into 60 s square. So this s and this is getting cancelled. So that's why it is written as 1080 into s. And hence numerator denominator and denominator denominator both have been made equal. That is 2s into s plus 1 s plus 2. So very small kind of calculation you have to do applying your mind. So what we are doing is this s and s square we are cancelling, so it is becoming 1080s, and denominator is 2s into s plus 1 s plus 2. Here also up denominator is 2s into s plus 1 s plus 2. Just cancel it. So take this 2s into s plus 1 s plus 2 here. Okay, like this, minus multiplication of all the numerators, that is 1080s, and then you keep on solving. It becomes, so divide by 2, so this becomes minus divided by s square plus 3s minus 538. Okay, so s square plus 3s minus 538 is called as system characteristic equation. So there is something wrong here. What you had to write was 0 is equal to, or s square plus 3s minus 538 is equal to 0. That is actually the system characteristic equation, and this is actually the system characteristic polynomial. So a square plus 3s minus 538 is the system characteristic polynomial, and b square minus 4ac. So if you find the root of this equation, as c is very big, definitely you will be finding that the system will be having imaginary roots. Okay, and then we can find out the roots of the system, and imaginary roots means a plus jb. So you have to check where does the a lie. Okay, so if a is in the there's a real part, where does the a lie? If a is in the left side of a plane, then the roots will be called as stable roots or stable ports. Likewise, so this is a closed loop transfer function. So the things that we can understand from here, it's a closed loop transfer function, and it's with positive feedback. As this is positive feedback, here we have written 1 minus. Okay, and whatever equation we are finding here, as is a closed loop system, this is called as a characteristic polynomial. The a square plus 3s minus 538 is equal to 0 is called as characteristic equation. And what is the feedback ratio? So feedback ratio they're saying as 60 by S. So what is the feedback gain? This one, 60 by S. This is the feedback ratio. What is the open loop transfer function? So here I'm telling you a very important thing. Okay, so what is closed loop transfer function? Closed loop transfer function is this. What we have found, CS by RS, that is G divided by 1 plus or minus GH. That is called as CLTF, closed loop transfer function. What is meant by open loop transfer function? So this is a very important thing. What is open loop transfer function? Whatever is the GS and whatever is the HS you get, multiply them. So what is the GS we get here? GS is 18s square divided by 2s into s plus 1 s plus 2. So 2 and 18, if you cut this at s and s square, if you cut, it becomes 9s divided by s plus 1 into s plus 2. So 18s square by 2s, that means 9s. So what is the forward gain? Forward gain is 9s divided by s plus 1 into s plus 2. Multiply that with 60 by s. Okay, so here you are getting. So this is first gain G1, this is first gain G2. So multiply them together and what you are getting is G. Here is a very important thing, loop transfer function or open loop transfer function, it's called as OLTF. Very important thing, we will be doing root locus, we will be doing Bode plot. At those times, this concept of open loop transfer function will come. This is not having any significance technically, but whenever we are doing a lot of theory, from the open loop transfer function, we can predict whether the closed loop system is going to be a stable system or unstable system. So something difficult at of higher level I am telling you now. From the open loop transfer function, what is open loop transfer function? G into H or GS into HS. Okay, that is called as open loop transfer function. Some methods are there, root locus, Bode plot and all these things, where this open loop transfer function will be given to you, GS into HS. And from there you have to predict whether the closed loop transfer function is going to be uh, stable or unstable. So a very important new term we are learning here, which is called as GS into HS, which is called as OLTF or loop transfer function. So it is 18 by S into S plus 2. This is the first G1. This is G2. So multiply G1 and G2. This is G multiplied by HS. So GH, okay, is going to be the OLTF. Feedback ratio is 60 by S. I have not given you this proof, but we can prove that. So only I have given you the proof of CS by RS. But ES by RS, what is the ratio of error with respect to input? That if you do, it will be 1 by 1 minus GSHS. For positive feedback system, it is 1 by 1 minus GSHS. For negative feedback system, it will be 1 by 1 plus GSHS. So this is the ratio of error with respect to input, not output with respect to input. Output with respect to input, CS by RS is GS divided by 1 minus GSHS. But error divided by output is 1 upon 1 minus GSHS. So you know the value of GSHS. So GSHS value is just found from here, 530 divided by s square plus 3s plus 2. Substituted here, then s square plus 3s plus 2 goes at the numerator, and s square plus 3s plus 2 minus 540, that means s square plus 3s minus 538, it comes at the denominator. So what is this thing called? This is called as an error ratio. Where will you use it? This ES by RS ratio will be used when we are doing steady state error analysis in the chapter number 3. Okay, but in this chapter we will be doing only CS by RS, that is the transfer function. So this is the page number 5 of my handwritten notes. It will be uploaded. So this numerical number 9 is very important. Okay, so try to understand this numerical. Why this numerical special? Because first time we are solving a positive feedback closed loop system. So 1 G divided by 1 minus GH, this formula we are using for the first time. Secondly, we are understanding what is the concept of open loop transfer function or OLTF. We have found CLTF first, closed loop transfer function, and after that we are finding what is OLTF. So OLTF is nothing but G into H, that's all, whatever you get. Then there is a concept of feedback ratio, and then there is a concept of error ratio. Error ratio is E by R, that is equal to 1 by 1 plus or minus GH. If it is positive feedback, it will be 1 by 1 minus GH. If it is negative feedback, it will be 1 by 1 plus GH. That is called as an error ratio. Whenever we are going to do the system transfer function and error analysis together, there we will be using this error ratio concept. Okay, so that was the preliminary so far. So since last uh, 2 hours, so 1 hour on Monday we had done, and 1 hour today we are doing almost. So we are around 15 minutes in our hand in this session. We are going to solve one or two numericals. So let us see what is the kind of numerical they are going to ask in the exam. Okay. So question is find CS by Rs. Now it doesn't matter whether it is given as C or Y, or whether this input is given as R or X. They can give anything. Okay. But this is a system. First, let us understand what is the system and how can we get entangled loop. Okay. How can we remove the entanglement? So what is meant by entangled? Check here. Okay, this G and H, they are can be entangled because here everything is in the forward direction. So this G2 is, so here one arrow is missed. Please don't miss the arrow. Okay, so this is the arrow forward. This is also an arrow forward like this. So from here, G2 is forward direction, G3 is forward direction, CS is forward direction. So this is called this line RS, GS. So RS, SP1. SP1 means summing point 1, G1S, another summing point, G2S, another G3S. So all these are forward path gains. So this is called as a main forward path. Okay. Now, what is this thing? This is called as a feedback path. Okay. So this is a feedback which is coming after G3. So between G3 and output, this feedback is coming. Okay, this feedback is coming after G1. So this feedback is open. So there is no problem. Okay, so this path is no problem. Whereas this path is a little bit problem because you cannot directly write this path or this block as G by 1 plus GH. You cannot write that because there is something is coming here. And check H1. What is H1? H1 is reverse. So H1 is one feedback path which is positive feedback path. Why positive? Because check H1 is coming and this is plus sign. So H1 is a positive feedback path. So this loop you can solve first. So G2 divided by 1 minus G2H1. This you can do. Okay. So again, I'm repeating, but check first. So this block, so G2 is in the forward direction and H1 is in the reverse direction. So this is going to be G2 divided by 1 minus. Why 1 minus? Because this is positive feedback. So this is going to be G2 divided by 1 minus G2 into H1. So that you are getting here. And that is getting multiplied with G3. So that is actually cascade. So whatever thing we are finding here, this is a closed loop system with positive feedback. This is G2 divided by 1 minus G2H1. That thing is getting multiplied with G3. So what we get here, so these three things together, what we're getting here is G2 divided by 1 minus G2H1 multiplied by G3. So one step I have missed, intentionally I have missed because it's very easy. So first step could be, so after this, first step could be this thing. So the whole thing can be, so nothing is given here. Again, another thing, just check. Nothing is given in here in the feedback path. So if nothing is given, you have to assume the feedback gain is 1. Okay, that means here h equal to 1. So what will be the overall transfer function? And it is negative feedback. It will be g divided by 1 plus gh because it is negative feedback. Now h is equal to 1. That means it is g divided by 1 plus g. Now it cannot be g because it is given as g1. So it can be written as g1 divided by 1 plus g1. So I think it is understood. So last time I'm repeating, so it is negative feedback and nothing is given in this. See that here it is given as H2, here it is given as H1, but nothing is given in this feedback path. Hence, when nothing is given, you have to assume it to be 1. So this is G1 divided by 1 plus G1 into H, and H is equal to 1. So that's why this is going to be G1 by 1 plus G1. This is given. Second thing, this block, top block, you should resolve first. That will be G2 divided by 1 minus G2H1. So G2 divided by 1 minus G2H1, and that whole thing is there in cascade with G3. So that's why these three things together is forming G2 G3 divided by 1 minus G2 into H1. So now you are finding that only one problem is there. That is, this is the only loop which is pending. Okay, so now this whole thing G2 G3 divided by 1 minus G2 H1 you have to take as a capital G, a forward path gain, and this H2 you have to take as a feedback, and this feedback is also a negative feedback. Hence whatever you are going to get is this is going to be G2 G3 divided by 1 minus G2S H1S like this, plus or divided by 1 plus G2 G3 this multiplied by H2. So here I have missed the steps. Okay, so this thing and this thing, whenever they are doing that reaction. So what it will be? Numerator will be G2s G3s divided by 1 minus G2 into H1. That is numerator divided by 1 plus H2 into this. Okay, that means this is G, this is H. The overall is G divided by 1 plus GH, because here is a negative sign. And this is actually G1 by 1 plus G1, and whatever you are finding here, this is a big block. Okay, they are coming in cascade. Then CS by RS is equal to this block multiplied by this block. So this is G2 G3 divided by 1 minus G2 H1 plus G2 G3 into H2. So whenever we are checking this numericals in the exam, we first check the final answer. Okay, first check the final answer. If the final answer is correct, then we go back. Okay, and if final answer is not correct, then we check till what point you are correct. Okay, so part marking is generally done here, but if somebody is getting the final answer correct, generally we understand the flow, and in one shot 10 out of 10 is given to that person. But this numerical is very easy, because here three loops are there and there is no entanglement. What is meant by entanglement? Shifting the takeoff point before or after some gain block, shifting the summing point before or after the gain block, all those things are called as entanglement. So whatever numerical will be asking in the exam, it will be little difficult. It will not be this easy, that there are three loops and which are open actually. So this is open loop. Not open loop does not mean it's open loop. This loop is very easy. It is not entangled. Okay, separate loop, not open loop. We should use the word as separate loop. So this is a separate loop. When you solve it, again the this multiplied by G3 and H2, they becomes a separate loop. Again G1 and 1, they are a separate loop. Now just finally multiply all those things. Okay, so very easily you have found out what is the transfer function. So this is a very easy transfer function. This can be asked for 5 marks, but not 10 marks. Now see another thing. Here there is an entanglement. So this is the last numerical that we are going to solve. So we are solving almost 11 points from my notes. So up to page number 6, or we'll go almost up to page number 7. So these are 7 pages from my notes that I have done. And previously also I have explained some 2 or 3 pages from my notes. So let us see what is the problem here. So the problem or pressure point in any numerical you have to understand. So here RS is given. This is the input, summing point 1, G1, summing point 2, G2, summing point 3, G3. There is no problem. Okay, but this is a problem, because you cannot solve. You are finding that this H1, which is a feedback signal. So there are 3 feedback signals. H1 is a feedback signal, which is negative feedback. H2 is a feedback signal, which is a negative feedback, and H3 is a feedback signal, which is coming from extreme output side to the extreme input side. Okay, so this H1 is an intermediate feedback, H2 is a output side feedback, and H3 is a output to the input side feedback. Okay, so first you have to understand. So this is the trick, this is the expertise you have to develop. First you have to understand because of what, okay, we cannot solve it. Okay, so only problem is if this point was not there, this point. So if this point was not there, or this point was right side, then very easily you could write it G3 G4 divided by 1 plus H2 G3 G4. But that you cannot write here. I'll repeat, if this point was not there, just imagine that this point is not here. That means this is a very separate loop, and the below loop is also a very separate loop. So in that case, this would have been, if this point was not there, then it would have been G3 G4, that is the forward path gain, divided by 1 plus G3 G4 H2. That is G1 H1 G1 divided by 1 plus G1 H1. So in this case, G1 should be G3 G4. So if this point was not there, then this transfer function could very easily be written as G3 G4 divided by 1 plus is coming because this is negative feedback, 1 plus G3 G4 H2. But we cannot write it because this is the problem. There is a problem, that is this point is there, and this is actually a feedback. Okay, so what we will do is we will apply the law. What is the law? Take this point after the G4. Okay, so take this point after the G4 block. So shifting the takeoff point and take it after the gain block. One thing you can see here, if you are taking it off from this point, okay, this is only H1. So whatever is the output here, that output is actually being taken and multiplied with H1. But whenever you are taking it output side, you can see that this signal is getting multiplied with G4, and then you are taking it the feedback. So this you have to understand. From here you will understand whether you have to do it h1 into g4 or h1 by g4. So this is no rule you have to mug up. You have to understand actually what is done. So whatever is the signal coming from left side to the right side, the signal comes here and gets divided into two parts. First part is getting multiplied with G4 and coming at the output side. Okay. And whenever you are taking this feedback from here, it is actually the signal is not actually multiplied with G4. So whatever signal is here, that is actually getting multiplied with H1 and given as the feedback. But to make all the loops separate, you have to shift this point from here to here like this as shown in the diagram below. So the signal was actually here between G3 and G4, but to make it separate, make the loops separate, you have shifted this point from here to the right side. Now what's happening? Now see the sequence. So all these inputs are coming. This thing had to be fed back, but this signal is also getting multiplied with G4 and then you are feeding it back. That means you are feeding back a multiplied signal. Okay, because this signal you had to multiply or this signal you had to feed back, but now this signal also is getting multiplied with G4 because you have shifted this point from here to the right. So now this signal is also getting multiplied with G4 and then it is being fed back. So what we have to do is we have to reduce the multiplied effect. So multiplying effect is G4. We have to cut that or we have to compensate for that multiplying effect. And how can we do that? This H1 is actually made as H1 divided by G4. So from here we are supposed to take the signal, but now we are taking the signal after G4. That means this signal between G3 and G4 getting multiplied and then coming at the output. So we can take it back, but we have to compensate it with a block of 1 by G4. And as H1 is already there, this H1 will become now H1 by G4. Now you can see that all the blocks are, that entanglement is not there. Okay, so I will again show it separately like this. So you have taken this signal from here to right side and then this kind of thing is there. Now you can very easily solve this. Okay, now you can very easily solve this. That is G3 G4 divided by 1 plus G3 G4 H2. Okay, now we have started solving. So many blocks you are supposed to draw in the exam. So one question or maybe two questions of this type will definitely be asked in your module 2. So please prepare this and prepare with diagrams. So diagram draw kar ke practice karo. Rough diagram you draw, scale and all these things you might not have to use. So I also have not used scale, but a very big mistake I have made is I have not shown the arrows. So this is very bad. So everywhere you have to show the arrow. As this is the main central line, all the arrows are from left to right. Okay, so everywhere you have to show the arrows. That is a very big mistake I have made. You please don't make this kind of mistake. Feedbacks I have shown very properly, but forward path, all the arrows have to be shown. Okay, so this circuit was given, and we identified the problem as this point is actually creating the problem entanglement here. How can you resolve this? Shift this in the right side. Now here you are not multiplying it with G4. Now if you are taking it, shifting it to the right like here, so actual feedback signal is getting multiplied with G4. Compensate that in the feedback path, that is H1 by G4 you do first, and then you just solve this. So now there are three loops. All the loops are very separate. You can find out. So now G3, G4, H2. Okay, they are forming a loop. And what is the transfer function? And there's a negative feedback. So this is G3, G4 divided by 1 plus G3, G4, H2. As soon as you do that, you will find that this G2 and this block is in cascade. So multiply that. So this will become G2, G3, G4 divided by 1 plus G3, G4, H2. So G2, G3, G4 multiplied by 1 plus G3, G4, H2. And that thing is in loop with H1 by G4. So that thing is solved next. That thing is solved next. And if you're solving it, so two steps have been done together. One step is G2, G3, G4 divided by 1 plus G3, G4, H2. This is one multiplication. And then this with H1, G4 forming a loop. So that if you are doing, what you are going to find is like this. So now see that now the G is G2, G3, G4 divided by 1 plus G3, G4, H2. Okay, and again 1 plus GH, so G2, G3, G4, 1 plus G3, G4, H2 multiplied by H1 by G4. What is H1 by G4? H1 by G4 was actually H1, but as you have shifted this takeoff point after G4, this H1 has become H1 by G4. Now in the denominator, what you have to do is you have to multiply it with 1 plus gh. So all the loops are negative feedback, that's why it is 1 plus gh. So multiplied by h1 by g4. Now this g4 might get cancelled. Okay, so now what you are finding is the forward path gain equivalent is becoming g1 g2 g3 g4 divided by 1 plus g3 g4 h2 plus g2 g3 h1. This now is becoming forward path gain, and now feedback gain is h3. So if you just mix it, what you will find is 1 plus g3 g4 h2 plus g2 g3 h1 plus g1 g2 g3 g4 h3, and numerator is g1 g2 g3 g4. That means this whole thing is now g, and the denominator and the feedback path, it is h3. So it will be g divided by 1 plus gh3, and in place of g you have to put this very big thing, that is g1 g2 g3 g4 divided by 1 plus g3 g4 h2 plus g2 g3 h1, and then you have to do this cross multiplication. And don't play smart, that is one very important thing. Do put some rigor and do this calculation easily, because एक G1 का G2 हो जाएगा, G3 का G4 हो जाएगा, तो the whole numerical becomes wrong. Okay, that's why don't take any chance, go slow, proceed step by step. And this is very easy actually, only this level of numerical will be asked in your exam. But don't make mistake in block reduction technique because you are hurrying or you're jumping steps, वो सब करने जाओ मत. Okay, go very slow, go steady, and solve the numerical properly. Okay, so we have completed up to page number 8, and next numerical is again a big one. So you can find here there is an entanglement. So this numericals and all I will be posting you later on. So this PDF I am not posting now, but whatever things we have done, whatever numericals we have done by today, I'll post it somehow. So either I'll make some arrangement and I'll post up to this numerical 11 in the group today. So these two lectures, if you do, this is the basic of block reduction technique. Now only we have to keep on solving many more numericals. There are no new cases. Whatever cases were possible for shifting of gain block, summing point, takeoff point, all the rules have been discussed, and few already we have started to apply. Okay, so that's all from me, and I'll be uploading all the videos and all the lectures and all the notes by today in your Google Classroom. So thank you for attending the session. That's all. We'll meet again tomorrow